Welcome to Spark Solvers. Charge up your skill, power up your knowledge. Today we are going to solve example of AC circuit, which is asked in Diploma Engineering. Subject is AC circuit and paper is GTU paper Winter 2023. Question is, from the equation V is equal to 141.4 sine 628t for the alternating current, find the following. First, maximum value of voltage. Second, frequency. Third, RMS value. And fourth, average value. A question also written in Gujarati for the students who studied in Gujarati language. So from the question, we can find the data. So in data, voltage equation is given. That equation is V is equal to 141.4 sine 628 t. Now, if we compare this equation with the V is equal to Vm sin omega t, then we can directly find the maximum value of voltage. Now, maximum value of voltage that is given by 141.4 volt. So this is our first answer. Now, second one is frequency. Now, to find out frequency, we again compare the equation with the V is equal to Vm sin omega t. So we can directly find the value of angular frequency, that is omega. So omega is equal to 628. Now we know that omega is equal to 2 pi f. So frequency f is equal to omega upon 2 pi. Now from the equation, omega, value of omega is 628. So 628 divided by 2 pi. So answer of frequency is 99.9, which is 100 hertz. So this one is our second answer. Now RMS value. Now RMS value of voltage given by Vm by root 2. Now we already find the value of maximum voltage, that is 141.4. So 141.4 divided by root 2, that is our answer for RMS value. So that is 99.98 volt. Again it is 100 volt. Then 4, last is average value. Now average value given by 2 Vm upon pi. So 2 into 141.4 divided by value of pi, that is 3.14. Answer is 90.01 volt. So these are the our 4 answers. Here the main important point is we have to consider the equation that V is equal to Vm sin omega t and compare the equation with the given one. So we can directly find the given parameters. Thank you. Subscribe for more updates, and you can send your query on sparksolvers.community@gmail.com. Thank you all.